Hey everybody, welcome to another video on your A+ 1201 exam. Today we're going to be having a look at exam objective if I can say that right, 2.3 is what we're looking at. So we're going to be trying to summarize services provided by networked hosts. So we're going to be looking at everything in here, and I'm going to tell you the kind of things you're going to want to pay attention to in relation to what you might be asked on your exam. And then at the end of the video, just like all of my videos, I'm going to give you some free practice questions and answers at the end of this video. So it's pretty much got everything you need in reality. So let's go ahead, get to it. I'll put my glasses on so I can see, and we will start swinging, starting off with the different server roles. All right, let's go. So the first one that we need to know about, you definitely need to know for your exam, is DNS. DNS, if we're not familiar, if we don't remember, if we are having a bit of a brain blank, is responsible for translating website URLs into IP addresses and vice versa. So basically what that means, we've got a nice little visual representation here. If you've got an IP address of 10.154.222.6, that's the IP address that the computer looks at and reads. But us as humans, we don't actually look at IP addresses. If you're going to go to journey2cyber.com, for example, subtle little plug, you're not going to type in my IP address. You're going to type in journey2cyber.com. So what a DNS server does is it stores the IP addresses, it stores the domain names, and it translates between them. So when you type in journey2cyber.com, it goes, oh, hold on, wait a second. I don't know what that means. I'll have to look up the IP address. Oh, okay. So they actually want to go to this IP address. Now I know where to take you. So DNS server translates between domain names and IP addresses and vice versa as well. That's pretty much what you need to know. So as we can see, right, this function is crucial for surfing the internet. We wouldn't be able to surf the internet without DNS servers doing that translation, because if it did not exist, we would need to memorize IP addresses. We wouldn't be able to use URL addresses, domain names, without DNS servers. So thank you to the gods of DNS. You're doing us a great favor, because I'm not trying to memorize all those numbers for when I go to menu log and order my Guzman, my burritos. I'm not trying to memorize the IP address. I'm just trying to type in givemeaburritonow.com. All right. So that's a DNS server. That's what you need to know. The next one that we need to know about is DHCP. Now, again, this should be ringing bells as well. DHCP servers are responsible for distributing your IP addresses. So long story short, guys, another little visual here. Let's say you've got a new device here, and it's just joining your network. It's just signed into the Wi-Fi, right? Or it's just been plugged into the Ethernet, for example. This device comes onto your network and it says, hello, I'm new here. Can I please have an IP address? At which point the DHCP server says, yes, I will allow it. And it gives the device a IP address out of the available IP addresses within its pool. So it may have a bunch of different IP addresses up here, right? And it's going to say, all right, which one of these are available? And it's going to give this device one of those available IP addresses. Now, you can make customizations, as it's seen here, to ensure a device is always given the same IP address. So think of a scenario, and you'll need to do this for your exam as well, where you might want to make sure a device is given the same IP address. All right. When would you want to do that? So again, that is done by matching the device's MAC address. Stop for a second and think, what is a MAC address again? We talked about it before. Can you remember? With the desired IP address. The next one is Fileshare. So pretty self-explanatory. It's in the name, right? A Fileshare server stores and manages, wouldn't you know it, files, allowing multiple users to access, share, and secure them within a network. So guys, right, Fileshare, pretty much, it's this situation over here. What's going on? You got a user here, user here, user here, user here, and they're all sharing files between one another. All right, the files are located here, and they can share those files. A Fileshare server is used to share files. There's really not much more there for me to say. And on your exam, it should be pretty clear when the correct answer is Fileshare server. Okay, they might try to word it a little bit funny, but I'll give you some practice questions at the end that'll give you an insight into what that might look like. But just understand, Fileshare server is for sharing files, right? You don't need to know much about that. There's some more details here that you could look at, right? It stores files, shares files. It can also control the access, or you can control the access, set the access as to who can access what files. You can make backups, of course, and you can track what changes have been made. So if anyone tries to make a change to a file, you can actually see who made that change and when. It assists with collaboration. So you might be asked a question like, when would a file share server be useful? And you might have to pick out of 4 different scenarios. Just for example, one of the correct answers would likely be an environment where multiple people are having to work together to share resources, right? Because you're sharing files. So pretty intuitive stuff, pretty intuitive. There's not much more for me to say. Just know what a file share server does. Moving on to a print server. Okay, so a print server, a print server manages print requests from multiple computers and directs them to one or more printers. All right, so essentially it acts as an intermediary, organizing and queuing print jobs, ensuring efficient and shared access to printers within a network. So this, as it states here, simplifies printer management and allows multiple users to easily share the same printer resources. So basically, in visual terms, we have all of these people over here, and they all want to connect to this printer. But if they all wanted to print, what they would have to do is they'd have to install the drivers on his device and his device and her device and her device and his device and his device and her device. They'd all have to install the drivers, and they'd all have to individually connect to the printer. It's a lot to do, particularly if you're in a large enterprise environment, right? So instead, the print server has the drivers installed. The print server has everything it needs. It's connected to the printer. And what these guys do is everyone in that organization, it could be everyone on that floor, everyone in that particular team, whatever, can connect to that print server, and they'll send their print job to that print server, right? So gets sent to the print server. The print server then says, hey, printer, I've got this print job for you. The printer says, okay, sweet. And then prints out the paper. And then Bob at the office finally gets his data report he's been waiting on. And he is just so excited to go home and tell his wife about that. He can't believe it. He is thrilled. Okay. So in short, print servers allow multiple people to access a printer without having to install the drivers there. So it's really good in corporate environments and enterprise environments where you've got a lot of people that need to print and you don't want to install the drivers on every single device. Long story short, that's what a print server is. If it has anything to do with printing, it's a print server. Okay, mail servers. What does a mail server do? Take a wild guess, right? It handles and manages email communications within a network. So you've got your mail server here. It's throwing the mail. It's delivering the mail to the user, right? That's pretty much what the mail server is doing. So it receives mail, it stores mail, it organizes emails, ensuring that messages are properly delivered and accessible. It's making sure the right people get the right emails so that Susan doesn't get the email that you sent to Bob talking about the fact that Susan ate all the brownies in the fridge because you saw her sneaking in early in the morning just to get those brownies, right? The mail server will make sure Susan does not get that email and it actually goes through to the person who you're meant to be sending that to. Okay, so it's really good to help as well because it has things like spam filtering, so you can make sure that, of course, if you've got spam emails coming in, mail servers have the capacity to try to filter out that spam. We'll talk a little bit more about that coming up. I think that's in this exam objective as well. Actually, we'll have a look. Okay, so we'll look at spam filtering specifically coming up soon, but mail server handles emails. That's pretty much what we need to know. Syslog. All right, this is a big one, particularly, I know I'm jumping ahead a bit, but as you go into your Security Plus certification, a Syslog server is something you're going to need to be pretty familiar with, and you also need to be familiar with it for this exam as well, as it turns out. So Syslog, long story short, is a server, so it's a server type that collects, stores, and manages log messages generated by network devices and systems. So it centralizes that log data in one place, essentially, right? So it's centralizing log data from multiple different sources in one place. So here's a visual representation for this. You've got device number 1 here, device number 2, device number 3, device number 4, and they've all got these errors happening. If you were trying to manage all of this on your own, you'd have to manually log into each device, look at the errors, try to catalog what these are, try to figure out what order you should try to sort these errors out in. Instead, these errors are sent to a Syslog server over here, which will often, and you don't need to know the specifics of these error codes, but it will have specific error codes, and they will say, this error is of very, very high priority. You should probably deal with it straight away. This error is not that, it is high, but not as immediate as the last one. This one's moderate, this one's low, right? So it'll actually categorize it all in one place, and it is essentially a way of centralizing your troubleshooting efforts in relation to any errors that you have. So if you're trying to identify issues, or you're trying to do auditing activities, maintaining security, you want to have a comprehensive view of events happening on the network, you would go to your Syslog server. That's where you want to go, because it summarizes all of those errors in one place. Really, really handy. And again, you'll need to know that for your Security Plus. So if you're going down the security route, cybersecurity route, you're going to need to know all about Syslog servers. Absolutely. Web servers, right? This one's pretty standard. I'm sure we can already guess what it's about. A web server is a system that hosts websites and delivers web content to users over the internet. So if you're hosting a website, you're going to be using a web server. If you're accessing anything on the internet, you're going to be using a web server. If you're going to, just for example's sake, subtle little plug here, but just for example's sake, if you so happen to be going to journeytocyber.com to get your copy of the learning guide, which has an endless amount of resources for fantastic value, you would be going to a web server. I had to do it, guys. I can't not plug myself, okay? So web servers are hosting websites, essentially, right? So if you're on a web browser, it's a web server, you get it. We know what a web server does. Pretty self-explanatory. So next one, this one's a bit more tricky. Not really, but it's more complicated than that. Is an AAA server, or Authentication, Authorization, and Accounting. All right. Authentication, Authorization, and Accounting. So it's basically in the name what this does. It does three main things. So it authenticates that you are actually who you say you are, right? That's the first thing it does. It also authorizes. So it's saying, okay, you are who you said you were, but what are you actually allowed to do here? I'm going to take your information and have a look at what the database says you're allowed to actually do. And then you've got accounting. And this is where it's tracking and recording your activities on the network and logging details such as when you log in, what you're doing, the kind of data you're using, the resources you're requesting access to, that kind of thing. And it's good for monitoring, auditing, and ensuring compliance with policies, because you can track who's doing what, right? So visual representation, if you're, let's say this is the AAA server. This is you. You join the network. As soon as you join, this server would say, are you Bob? Or, who are you, right? So, are you Bob? Yes. This would look like a login screen of some sort, right? Maybe it would have a login screen with a password. You put that in, you are authenticating to the network. You're saying, this is who I am, and I can prove that this is who I am because I know my own password. Okay, great. I know you're Bob. Is Bob allowed here? Yes, it's not really going to take your word for it. It's going to go to the back end and have a look. Okay, this is what Bob's allowed to do. Does it say Bob's allowed here? Yes, absolutely. Great. Or no, in which case, sorry, buddy, you're not getting in, right? And then finally, once he lets you in, it's like, all right, I'm watching you. I'm going to watch everything you do. And then you say, yep, sounds good. That is what I have to do in order to use these resources. Thanks, no worries. Sounds good. So that's AAA, Authentication, Authorization, and Accounting. Just know the three main functions that it does, and you should be able to identify it in the exam. All right. Next, we've got a database server. So a database server stores and manages data, right? Again, it's in the name, ensuring it's organized and easily accessible. It runs specialized software known as DBMS. So it has that specialized software called DBMS that handles data operations such as querying, updating, and securing data. All right. So it has backup and recovery features to prevent data loss, and it optimizes performance for efficient data access. So in essence, right, in simple forms, it's a central hub that stores and manages all of your data, making it available whenever you need it. So a database server holds on to data, just like this guy. He's desperately clinging to this data. Database server is holding on to data. All right. He's saying, I will hold this. This is my data. He loves that data. That's a database service. Server, sorry. And finally, the last little bit in this one is the Network Time Protocol, or NTP. Again, as with all of these, you'll need to recognize it by just the letters alone, guys. NTP, Network Time Protocol, or NTP, is a protocol used to synchronize the clocks of computers on and devices on a network. So these servers basically rely on time servers that provide accurate time information, usually sourced from atomic clocks or GPS systems. Long story short, really, really accurate clocks, dead spot on. And when you synchronize with these servers, so they will contact the NTP server to adjust their clocks, making sure their time is the same time as the NTP server. All right, that's about what you need to know. Really, for the sake of your exam, you won't really need to know the intricate details. You just need to know what is a network time protocol, how do our computers keep their time and make sure they're telling the right time. They use NTP or network time protocol. Okay, so that's pretty much it. Now, we're going to go into internet appliances, but before we do, for all of that, guys, for all of these servers that we just had a look at, what you're going to need to do on your exam, essentially, is you're going to need to make sure you can do a few things. The first thing is you're going to need to make sure that you can identify when any of these are being used. Okay, so you need to be able to be given a scenario and say, oh, they're using a Syslog based on the scenario that they've presented me with, or oh, they're describing a mail server based on the scenario they're presenting me with. Or alternatively, you will need to you'll be given a set of requirements, and you may need to recommend a particular type of server that you know, oh, okay, they need this done. This is the type of server that does that job. This is what I'm going to recommend. All right. One of those two things is the most likely outcome that you'll need to do on your exam. Now, let's go ahead and jump into the next one, which is internet appliances. So we're looking at spam gateways, guys. I told you we'd be dealing with spam management a little bit more coming up, and here we are. Internet appliances, spam management, spam gateway, sorry. So it's an internet appliance. Spam gateway is an internet appliance designed to filter and block unwanted spam emails before they reach users' inboxes. So, you know, we've got, let's say we've got your inbox over here. You only want to let your special mail in. The spam gateway uses criteria. You know, it'll be able to detect what messages are good and what messages are spam and need to be rejected. Long story short, okay? Largely at a large scale, that's what you need to know. There are some more specifics here that you can have a look at as to how it does it, right? So it has email filtering, which scans incoming emails for spam, phishing attempts, malware, and other malicious content. It has real-time blacklists, which uses lists of known spam sources to block emails from those addresses. It does a bunch of other things, right? You don't need to know in detail all of these. You can pause and have a read. For the sake of keeping this video rolling, I'm going to keep a move on, but you just need to know Spam Gateway is an internet appliance that stops spam emails getting through, right? So we'll go to Unified Threat Management, okay? Now, Unified Threat Management, before we get to the notes, we're going to take a look at this guy. Look at this guy. What do you think about him? He looks pretty beefy, right? This is my attempt at drawing muscles. I know I'm not the best drawer, but it's the best I could do. So he's got a sword. He's got big muscles, he's got a shield, he is ready for battle, right? And that is pretty much what Unified Threat Management, or UTM, is. It is a security solution that combines multiple security features into a single device or software to protect networks from various cyber threats. So it may combine a firewall with antivirus and anti-malware, with intrusion prevention system, otherwise known as IPS, right? It will combine multiple different security functionalities into one device, otherwise known as, it's pretty much in the name, right? Unified Threat Management. They're all coming together. It's kind of like the Avengers, right? They're all coming together in one piece of hardware or software to fight against security threats. So you can have a hardware UTM, which is a physical device that you plug into your network, or a software UTM as well, which is a program that you'd install on your computer or server that would functionally do the same thing. All right, so that is what Unified Threat Management is referring to. And then we've got load balancers as well. Okay, we've got load balancers. Now, load balancer is a device or software that distributes incoming network traffic across multiple servers. So it's distributing it, making sure it's all happening evenly. The main goal is to ensure no single server becomes overwhelmed with too much traffic. So that's going to improve overall performance, reliability, and availability of applications and websites. So here's a visual representation of that. you've got your load balancer here, and you've got four servers, sorry. Now, each of these servers is handling a certain amount of data. So this one's handling data that's about up to here, this one's about up to here, this one's about up to here, but this one seems to be dealing with a lot more data. So the load balancer might have a look and say, okay, you know what? I'm going to deliver more data to the servers that have less, that are currently handling less data, because this one's already dealing with enough. So I'm going to actually reduce the amount of data that I'm giving to that one to make sure it doesn't get overloaded. It stays up. We maintain our uptime and availability. Load balancer, that's largely the functionality, right? So it distributes traffic, makes sure everything's running smoothly. Pause and read all the details if you want, but I've pretty much given you the main concept that you need to know for your exam. A proxy server. Now, a proxy server acts as an intermediary between a user's device and the internet. So an intermediary, it's someone in between, right? It's someone that's standing in between you and the person that you're sending data to. It processes requests from the user and forwards them to the appropriate web server, and then returns the response back to the user. So let's have a look at a visual representation of that. You've got a proxy server here, you've got you over here, and you've got the person you're sending the data to over here. If you were to send the data on your own, right, you would have your IP address clearly listed, and they'd be able to say, oh, hold on, I know that person, I know who that is. But if you go through a proxy server, they are going to see the proxy server's email address, right? And they're going to look, hey, I don't actually know who that is. So if you send your data to the proxy server goes, okay, yep, sweet. Let me just have a look at that data. I'm going to send it to who you're sending it to, and then we're off. And then the person you're sending it to is like, oh, hold on a second. Who is that? I don't even know that IP address. There's no way I'm going to be able to track them down. Is it really fail safe? No, but for the sake of your A+ 1201 exam, you just need to know a proxy server stands in between you and the person you're sending it to. You send data to the proxy server, and then they can send data on your behalf. All right. Now, some key functions of it, you've got anonymity, so it can hide your IP address, as I just discussed there. You've got content filtering, so it can block access to specific websites or content based on predefined rules as well. It can often be used by organizations to restrict access to inappropriate or non-work related websites. Absolutely. Security provides an additional layer of security by filtering out malicious content before it reaches the user's device. And this is a big one it does as well, caching. So, right, it has that anonymity factor where you can hide your IP address, but it also stores copies of frequently accessed web content to speed up future requests. So what that would look like is you might, let's say the internet is over here, right? You might frequently be saying, you know what, I need to access the internet, so I'm going to go all the way over here and get this data. Oh, I need it again. I'm going to go all the way over here. Oh, I need it again. I'm going to go all the way over here. Or instead of doing that, what you could do is you could actually get the proxy server to store the data that you're accessing on a frequent basis here. So that way, in order to access it, you actually don't need to go all the way over there. You can just go here. That's a much shorter distance. You're going to get a much faster response time there. Okay. So just an example. All right. Now, we're going to go on to a final little component of this exam objective before we get to our practice questions. All right. We also need to know about legacy/embedded systems. So it's kind of in the name for the legacy, right? Legacy basically just means outdated systems or software that are still in use. So you've got a really old piece of device, really old piece of software, really old piece of hardware. Generally, they're a security risk because they are often no longer supported and they've stopped bringing out patches for them. And generally, they don't have any of those modern capabilities, right? Sometimes we end up keeping them around just because we need them to do the specific job that needs to be done, or we don't want to upgrade. It's too much hassle, might cost too much money, etc. But they're generally considered a security liability because they can't get patched. Okay, so that is an important thing to keep in mind, right? On the other hand, we have embedded systems. Okay, now this is one that took me a little bit to get my head around when I was first studying. An embedded system is a specialized computing system that is integrated into other devices to perform specific functions. So it's a system within a system, right? So let's say you've got a device of some sort, And this device does a whole bunch of things. It does this and this and this and this and this and this and this. Could be whatever. But then within that system, you've just got one little system, one little tiny device, and it has one job. It does one thing. All right. That is an embedded system. It's like a system within a system, and it just does one thing, one purpose. All right. So that is the definitions of those. We're going to go ahead and have a look at how they might operate in some examples coming up. But an example that we do need to know for our exam is SCADA, or Supervisory Access Control and Data Acquisition. SCADA. What is SCADA? You'll need to know. You'll need to look at your exam and be able to say, oh, they're talking about SCADA, right? You're going to need to be able to do that. So let's make sure you can. SCADA, or Supervisory Control and Data Acquisition, is a system used to monitor and control industrial processes. It collects data from sensors and equipment in real time, processes that data, and displays it to operators, allowing them to supervise and manage operations efficiently. So what does that look like, right? Functionally, it might look something like this, right? Very old school style room, right? You'll have a wide variety of monitoring devices that are monitoring some sort of functionality, right? It could be anything, but it's going to be some sort of industrial function with a lot of different devices in there that are measuring things like temperature, things to that effect. Okay, so it's kind of both legacy and embedded. It's legacy because look at it, it's pretty old, right? It's been around for a while. It's quite an old thing that is still in use, right? And it is embedded because, let's say, this might be an industrial site with lots of different monitoring tools, and all of these sensors, let's say, just for example, we've got a sensor here, we've got something over here measuring the temperature, or for example's sake, I don't actually know what the specific room is or what these specific things do, just so that you have the information for your exam. And that's where the action happens. Those things are sending that information back to the monitoring room, right? Now, it's very old, very, very old, generally quite outdated, and is considered a security risk for that reason. It is a legacy system, SCADA. And also each of these sensors, each of the individual devices here that are doing one purpose within this larger scale machine would be considered an embedded device. They are a device within a larger scale, a device within a device doing one thing, all right? So that's why SCADA would fit into that idea of legacy and or embedded systems, okay? Now let's go ahead and keep doing some more reading. So SCADA is a system used to monitor and control industrial processes. So if you see the word something industrial is happening, something is monitoring it, that's going to be your first giveaway in your exam that you're talking about SCADA. It collects data from sensors and equipment in real time, processes that data, and displays it to operators, right? We talked about that. It does a bunch of stuff, right? But basically what we need to know is it is often used in manufacturing, energy and utilities, water and wastewater, oil and gas, transportation, very industrial type things. It's measuring, it's sending that information back, and that data is being analyzed and interpreted and used, okay? The last thing, I believe it's the last thing we need to know, is Internet of Things, IoT devices. So if you see IoT, it means Internet of Things. In short form, it's basically all those tiny little everyday devices that you might use often for home functionality that do connect to the internet for some purpose or another. So the official definition is that they are devices that are physical objects embedded with sensors, software, and other technologies that allow them to connect to the internet and exchange data. Generally, it's for very simple purposes though, like I said. So for example, let's find the examples, because I think that really drives it home. You got these smart home devices, smart thermostats, smart lighting, smart security cameras, smart appliances, fitness trackers if you're doing wearable devices, smart watches, right? Things that connect to the internet to make life a little bit easier, right? So if it connects to the internet, it's relatively simple and it doesn't fit into the category of embedded or legacy systems. It's probably Internet of Things. Like a fridge that connects to the internet, that's Internet of Things device. A thermostat that connects to the internet, that's Internet of Things, right? All these little tiny things that connect to the internet would be considered Internet of Things. Pause and read the rest of that if you want. But that's pretty much it, guys. It should be pretty simple to see Internet of Things in action, all right? Just know those little things that connect to the internet That's pretty much it, guys. Pretty much it. All right, let's go ahead and get into our questions. Question number 1 reads, a network administrator configures a server that automatically assigns IP addresses, subnet masks, default gateways, and other network settings to devices as they connect to the network. This dynamic allocation of network configuration data ensures that each device is properly configured without manual intervention. Which server type is being described? A. DNS, B. DHCP, C. Fileshare, or D. Syslog? Answer coming in 3, 2, 1. Pause the video if you need to. Here we go. It is DHCP. So we should know, guys, that DHCP is a server that administers IP addresses. That was the dead giveaway. We also had DNS, Fileshare, and Syslog as potential options. Pause and read if you need to go over them again if you got that wrong, but hopefully you got it right. I'm going to go ahead and move on. Okay. The next one reads, an organization sets up a server that manages large volumes of structured data and allows multiple users and applications to store, retrieve, and manipulate information efficiently. This server type is crucial for handling transactions, managing inventory systems, and supporting applications that rely on organized data storage. Which server type is being described? A. Print server, B. Mail server, C. Web server, or D. Database server? Pause the video if you need more time. Answer coming in 3, 2, 1. The answer is D. Database server. Now, guys, you might be thinking, wait a second, it said multiple people could share data with one another efficiently. That sounds like a file share server. Absolutely, guys. If file share server was an option here, that would have been the most correct choice as far as I'm concerned, right? But it wasn't an option. So at that point, it's simply a matter of, is it a print server? Are we talking about printing? No. Is it a mail server? No emails are mentioned. Is it a web server? We're not talking about accessing a website of any kind. So it's a database server. It's storing data. People can go in, take data, store data, right? That's what a database server is, 100%. So hopefully we got that one right. Next question coming up. The question reads, a company implements a server that ensures users provide valid credentials before accessing critical network resources. Once authenticated, users receive specific permissions based on their role, and the system tracks their activity to maintain security and compliance records. This setup is commonly used in enterprise environments to regulate access and monitor usage. Which server type is being described? A. AAA, B. Time server, C. DNS, D. Syslog. Pause the video if you need more time. Your answer coming in 3, 2, 1. It is A. AAA. We were talking about authentication, authorization, and accounting. So remember, guys, that's the server that says, wait, who are you? What are you allowed to do? And I'm watching you. All right. Pause if you want to read if you got it wrong. Time server, DNS, and Syslog. Otherwise, we're going to go ahead and move on to the next one. The next question reads, a business installs an internet appliance that acts as an intermediary between users and the web. This device helps enhance security by filtering requests, caching frequently accessed content, and controlling internet access policies. It is commonly used to improve browsing efficiency and enforce access restrictions in corporate environments. Which internet appliance is being described? A. Load balancer, B. UTM, C. Proxy server, D. Spam gateway. Pause the video if you need more time. Your answer coming in 3, 2, 1. The answer is C. Proxy server. So guys, a proxy server is that one that acts as an intermediary between the person sending and the person receiving. Okay, it does all that stuff we talked about. If you got that one wrong, go back and have a look. Load balancer is the one that says, okay, let's make sure the servers aren't being overloaded. I'll give the right amount of traffic to the right amount of servers to make sure that they're not being overloaded too much. UTM was unified threat management, and the spam gateway was looking at managing that spam emails, filtering out the spam so you only get the emails that you want to get. The final question reads, an organization continues to rely on outdated software and hardware that, while functional, lacks modern security features and compatibility with newer technologies. These systems are difficult to upgrade due to high costs, specialized configurations, or dependencies on older applications. While still in use, they pose risks such as security vulnerabilities and maintenance challenges. Which type of system is being described? A. SCADA, B. Legacy systems, C. Embedded systems, or D. IoT. Pause the video if you need more time. Your answer coming in 3, 2, 1. That was legacy systems, guys. It talked about outdated software and hardware that remain in use despite lacking modern security features. Now, guys, this was the correct answer. It may have been possible for you to have got that wrong, not because you don't know what these are, but just because we may not have read the question correctly, right? A lot of these are related. For example, SCADA uses a lot of legacy systems, but it was not the correct answer, right? The most accurate description here is legacy systems because it was really focused on that idea of outdated software and hardware that remain in use. It didn't talk about being used in industrial settings. It didn't talk about real-time monitoring. It was just talking about basically being a legacy system. Embedded systems, there wasn't much mention of embedded specifically. Legacy does not equal embedded. And Internet of Things, remember we talked about what that was. That wasn't so much an option here. Now, guys, if you enjoyed this and you want to see how ready you are for the real thing, if you've completed the whole video course and you want to test yourself, I've got a free practice exam. You can click the link in the description or in the pinned comment of this if you want to test yourself. It's got 90 multiple choice questions and 3 performance-based questions with detailed answers and everything you need. You've got performance-based questions, you've got multiple choice questions, and if you're ready for the learning guide, which I have over at journeytocyber.com, it's given people results like this in the past. This guy says, update your notes definitely helped me pass my test today. Thank you. No worries, I'm glad I could help. This one says, your learning guide is actually goated. I don't comment a lot, but it definitely helps with organized information and helps me piece things together more easily. Glad it helped. No worries at all. And this one says, I just passed my 1102 on the first try. You saved me. And finally, I downloaded your learning guide already and I can see it will help immensely with studying. I tried some other popular resources but struggled absorbing the material. Will you have one available for A+ 1102 Core 2? Spoiler alert, I do for the 1102. But basically, guys, this was all based on my original learning guide. So all these success stories were based on my original learning guide. I think this one was actually just a YouTube comment here. But the other 3 based on my original learning guide. So I have taken that and supercharged it, right? What I've got in this new one for the 1201 is I've broken everything down by exam objective. And within each of these exam objectives, you've got multiple choice questions, active recall questions, notes on everything you need, detailed explanations. So here you go. Here's an example here. Multiple choice questions broken down by exam objective. So you know exactly where to study. You've got performance-based questions here. This one in particular is on networking and ports and protocols. I also give you a video on how to 10 times your learning with free AI tools. So for those topics that you're particularly struggling with, I show you how to really quickly close those knowledge gaps using 2 techniques with 2 free AI programs. And I also tell you a specific technique that I like to use when I'm using multiple choice questions to study. So you could get my learning guide, watch that video, and actually study like 25 times faster and more effectively and more efficiently than you would be able to without this technique. Because most people will just say like, oh, you know, I'll read the question. I think that one's right. I got it right. Sweet, I'm ready. Then they'll take their exam and they'll flunk because they didn't actually use the questions to study right. They weren't as prepared as they thought they were. If you do what I say in this video, you'll make sure you're actually ready. All right. So with that being said, guys, I will see you next time. Grab the learning guide if you want. Make sure you take that free practice exam if you want. And I'll see you in exam objective 2.4, I think is the next one. All right. Thanks, guys. See ya.